Ladies and gentlemen, the Greek legend, Alex Goulis from RateTel. He'll be telling about creating a large, scalable, and redundant voicemail cluster using OpenSIPS and FreeSWITCH.
Δείξ' τους ποιος είσαι.
Ευχαριστώ.
How's everyone doing? I know we're kind of almost to the end here, so I'm going to kind of blow through this more from a methodology and how we're doing it perspective. I'm not going to really get into a lot of the details of configurations, but by the end of the presentation, you should have a pretty good idea on how to do this, both successfully and effectively. So real quick, a bit about me. I've been designing multi-tenant large VoIP platforms since 2009. I'm the lead developer for RateTel's trunking and PBX products and platforms. And I'm actually the first OpenSIPS certified professional, which is nothing any of you could ever say you were.
Is it still valid, the certificate?
I didn't know that it had a half-life. So I'm going to go over some quick advantages of using OpenSIPS. Most of you are pretty familiar with these, but you know that it's a pretty highly scalable system. It's got a really stable code base. Our development team is really anal about providing really good code. It can handle tens of thousands of registrations and calls. I mean, the scalability has got all kinds of stories revolving around it. Provides a central point for billing, presence, all kinds of things like that. Dynamic routing, pretty amazing tool in the OpenSIPS toolbox. Really lets you create dial plans and routing plans that are just a far above and beyond what most companies, or rather pieces of software, can do. One of my favorite things is its ability to packet mangle. I'm really excited to be able to just rip packets apart, put them back together. And again, it's highly available. Some basic advantages of using FreeSWITCH. According to David Duffett, this is wrong, but it supports more concurrent calls than most other open source PBXs, including Asterisk. Rich media handling capabilities, lots of different ways to interact and configure it. Flat XML, Lua, Dynamic XML, ESL, JavaScript, basically just about anything. Tony and the guys over there are really, they're really, can I put this, in favor of like getting as many types and ways to connect with FreeSWITCH as they can provide. Again, stable code base, and I had a long time affinity with the OpenSIPS project. We've worked together on a lot of things, and actually one of the things I'm going to mention in the presentation was born of a relationship between OpenSIPS and FreeSWITCH. And it's got so many class 5 features that, you know, it's got things you don't even know about, cutting edge stuff that Tony and the guys are working on. Those of you that actually read the code might actually get some hints from, the source code rather, might get some hints as to where that is or where it's coming from. But it's an amazing platform. So let's just kind of go over the tenets of what should be a highly available system in regard to voicemail in specific. So on the network, you really want to have an edge that's highly available, not just inside the DC where all your applications are, but also across DCs. Obviously, anyone that runs a business around here knows that you can't just live with a single point of presence. Sooner or later, you're going to kind of get kicked between the legs. The VM servers, in this case, should be split across redundant network connections as well as power connections. The same would go for the hardware in the database layer, but the database layer should be replicated and available across all DCs on a geo-distributed type of scenario, as well as the storage layer. It's got to be replicated and available across all DCs. So in pretty near time, all the data revolving around your voicemails and all of the files associated with them have to be pretty much real-time available in any DC. So some of the network choices that you're going to have as far as making OpenSIPS highly available, we've seen a lot of that here. Clustering with OpenSIPS now is a really great way to distribute your edge. You know, the old methods of using hot and cold standby with VRP or similar IP sharing tools inside the DC. And then when you're trying to create, geo-available networks, you're going to use something like BGP, you'll use DNS SRV to redirect, or Anycast to geo-distribute. So the VM FreeSWITCH layer itself is pretty much done. The boxes have to be there, their configurations have to be available, and traffic needs to get to them. From a perspective of geo DC to DC, their interfaces don't have to be available, geo distributed. Basically, the information that they associate with the database and the actual voicemail files, those are what have to be distributed, and we'll talk about that storage layer and the DB layer in a second. One thing that you want to make sure you do, though, is you want to keep plenty of resources in reserve. So if you have multiple DCs, fine and dandy, you might be running, let's say, at 30% capacity at a single DC, but you have to plan for the convergence of traffic. Let's say a DC goes down, or even two DCs go down. The good thing about the FreeSWITCH layer, though, is that it exists on a private network. We use public to private bit bridging with OpenSIPS, which thus reduces the chances that these things are going to get hit with network events. Most of those network events, DOS attacks, SIP floods, those types of things, it really can affect the load on the box. And when you're trying to do load balancing, you want to be able to take into account all the different things, including the load on the box itself. And effectively, we feed the data to the FreeSWITCH layer using XML curl, connecting two web servers that are actually parsing the data out to it. So for the database layer, the first thing you want to handle and be really good at is replication inside the DC. You want to be able to have multiple database servers that can stay up when they're hit, spread load across, and then based on your choice of DB backend, you have different replication techniques that are available to you. You want to tackle the challenge of geo-distributing your data with consistency in mind. Most important thing, obviously, is that you're going to have multiple clients hitting different data centers, hitting different FreeSWITCH boxes. At the end of the day, you want to be able to bring all that data together and know that whichever box you're interacting with has the most real-time data available to you network-wide. And in some cases, you actually can use the storage layer as well, the database layer as a storage layer as well. Some DBs will support object storage, MySQL for instance, and you'll find some people actually using that and then replicating the DB layer and in turn replicating the storage layer in the process. So the storage layer is a little different. It's not just replicating, it's actually replicating a lot of data. It's not just DB entries. Voicemail recordings in general aren't necessarily the size of call recordings, but some of them could be really big. You're talking about massive amounts of data that you have to worry about not just inside the DC, but replicating across all DCs. So the biggest challenge in geo-distributing is usually it doesn't come up until you actually your data footprint starts getting big. From the inception of your plan and the spin up of all your services in the DCs, you're not really going to see a lot of problems associated with load, transferring large amounts of files between data centers, worrying about what the storage capacity looks like inside the data center. But what you want to make sure you do is you plan for the future from the start. So choose a piece of software or choose an environment that was built with geo-distribution in mind. Some good examples of geo-distributed file systems, GlusterFS, Ceph, and then you could choose to use something like S3 rather than store everything locally, push it up to Amazon, make the connections from all your data centers and pull the data in. And for anybody that needs to be, let's say, HIPAA compliant in the US, we have certain scenarios where we have to maintain privacy of data for anybody's healthcare information. And unfortunately, voicemails, call recordings, and in some cases even CDRs with caller ID names on them can be considered patient data. So what you need to really worry about on top of the storage layer is security as well. So basically a multi-tenant configuration in OpenSIPS, because you're going to be serving multiple tenants, you have to be able to decide where you're going to group all the voicemail boxes and by tenant. We use the load balancer module because it allows you to basically catalog all the FreeSWITCH servers inside the DC. It automatically handles server failure and server recovery. It pings and monitors all the servers in its list, checks them, are they healthy? If they are, keep them in. If they're not, take them out. And one of the nice things actually in the 2.4 branch is now we're getting a little bit more information about the FreeSWITCH servers. We have a new feature inside the load balancer module that can actually attach to the FreeSWITCH ESL, and it brings us back some load statistics so that we can make better decisions about how we want to distribute the traffic across the voicemail layer. And another thing, most importantly, is that it's pretty easy to add and remove servers. So from a scalability perspective, you have to do nothing more than just replicate a FreeSWITCH server that's sitting in your configuration right now, add its IP to the list, and now you're scalable N+ horizontally. So to give you a little idea about what we use, with OpenSIPS, inside the data center, we use an HA setup with VRRP and a shared IP. And that just maintains our edge, specifically to, make sure that we have no failure inside the DC. You want redundant network connections, obviously. I mean, these are basically things and tenants that you do in any HA situation when you're developing your platform. And you want, if you can, cross connects between DCs. Should the DCs, internet connections go down, in some cases your cross connects will stay up. And then to basically balance between DCs and then to deal with failover in HA, we use DNS SRV for geo failover. So effectively all of our customers have their own domain, which then we repoint as needed using the SRV records. We primarily home people in a primary and a secondary type of situation. And at some point or another, it's going to be good practice to physically shard your customers. You don't want to just have to manage this system in worrying about load when people might just suddenly routes on the internet change. And if you're doing just, low latency routing, suddenly everybody hits a data center and it doesn't become very efficient. So if you set your customers up in like a primary and secondary type of fashion, you at least have some control about the volume of customers and traffic that you're putting into each DC. On the DB side, we use MariaDB with Galera between the DCs. We found it to be an amazing tool for replication. Basically, replication in Maria is store something in InnoDB, and it's in the InnoDB table everywhere on any node. It's basically capable of writing to all nodes. It's a multi-master type of system. And we use Gluster for the geo-distributed storage. Gluster's amazing in the sense of not just inside the data center, but you can actually connect disparate data centers and boxes and give yourself one large central storage with resiliency and redundancy. So just a quick little look at what we use inside the DC. This is basically the common setup. Does this thing have a pointer, Dan? Where are you?
Yeah.
It does? It has a red dot?
Yeah.
Where is it?
The middle. Where is the middle?
No?
Yeah.
Okay.
The middle button.
That one?
It works only with
Oh, super.
I showed.
Oh, you have to twist and then hit the middle.
Yeah, and then you have
Left and right now. Thanks, Dan.
Sometimes it doesn't work.
Great.
Good luck.
As he's running away. For the light. Okay. So inside the data center, 2 OpenSIPs with a shared IP. We have 2 MariaDB servers. We use web servers to actually, like I said, feed the XML data to FreeSWITCH. And then the FreeSWITCH servers running each a Gluster brick. RTB proxy is just there basically to do our public to private bridging to the inside or the LAN side. And like I said, UCARP or VRRP to share the IP. It's a pretty basic setup. It's mostly what everyone uses in their class 4, class 5 setups. The thing to take note though is that in this case, MariaDBs are actually, they're replicating out to the other data centers. And the Gluster the Gluster storage is replicating out to other data centers. Even though we're inside the same data center, those 2 things are pointing out and replicating your data across all your DCs. And then between the DCs, really the only thing we do is we use a DNS SRV. You can use BGP. You have lots of other options, Anycast. effectively you have your two DCs that are separated on the network side, but from the DB and the storage side, it's one big cluster. So let's talk real quick about the module that we use inside of FreeSWITCH. It's called Mod XML Curl. It's a module that's used to feed real-time data to FreeSWITCH, including configuration data. So effectively, you don't need to do anything in the XML directories of FreeSWITCH. All the data can be stored inside this module in the database, and it'll pull everything at configuration time. It's simple to implement. You can use different languages like PHP, Python, Java. And FreeSWITCH curl is also available from the FreeSWITCH contrib tree. And that actually provides a pretty good primer. The database information is there. The initial PHP information is there, but it gives you everything to interact using MySQL, a web server, PHP, and FreeSWITCH. And in our case, we use in PHP, we use the XML writer to actually split out and push out all of the XML required to get to FreeSWITCH to do all the beautiful things we wanted to do. So just some points about MariaDB and Galera. It's synchronous replication. It's active multi-master topology. Read and write to any cluster node. Just save it in an ODB. It's done. Automatic membership control for failed nodes. It drops them from the cluster. Automatic node joining. True parallel replication on the row level. And it's basically MySQL. Maria was a fork of MySQL. So there really isn't a lot of learning curve for any of you MySQL fans out there. From the website to serve and run all the PHP, we use Apache Web Server. It's the most widely used HTTP server out there. Really good built-in support for PHP. Really easy to scale with Nginx. Super resilient, super cheap when you're trying to give yourself some type of distributed backend to provide, store configuration and dial plan information to FreeSWITCH. And like I said, we use it to serve the XML configuration files to FreeSWITCH for the VM configuration. So we use PHP XML writer. It's shipped with PHP, easy to understand, simple to use. Makes your life really, really easy rather than having to just sit there and code out a bunch of XML documents and drop them into directories. So just to kind of give you an example, like this would be an entry, or rather a directive for FreeSWITCH when somebody were to hit something in the dial plan for voicemail. And as you can see, the XML writer just pretty much breaks out each one of them, lets you write it out, closes it up, and ships it out very nicely. So some insights about this configuration. FreeSWITCH has no registrations. And in most cases, when you're using voicemail and FreeSWITCH, the registrations are there, and everything kind of works together really nicely, MWI, all that kind of stuff. Well, in this case, because we're distributing, and we've got our registrations up at OpenSIPS, we have no need for them down here. It's a pretty much dumb, configuration. Whatever it's fed, whatever it's pulled based on the dial plan, it's going to do, but it has no ability to really attach to the end users and send them things like MWI, for instance. So we use hang-up hooks in the dial plan in FreeSWITCH, and then we fire our own MWIs at any given, using a PHP code, checking the DB for, what the status of the voicemail box is, and we just fire off something to OpenSIP that looks just like an MWI notification. FreeSWITCH can handle a lot of different codecs, and as a result of that, you're going to run into situations for transcoding. What you want to make sure you do is take that into account when you're planning the system. Check with your providers, or you know things are going to come in on a specific codec, or do you know that you're going to have a lot of mixing. If you can shard the providers by codec type, which you can do also using the load balancer module with a little bit of logic in the back of it. So if you can do that, that's great, but at the end of the day, you still have now in 2.4, like I said, this ability to reach into each FreeSWITCH server, get an idea of what its load is at the current time, and make better decisions. One of the things in a highly, or rather even just like a highly used system, is that you want to try and not use disk as much as possible. And it's not very well known that FreeSWITCH's voicemail module actually has a setting in it that allows you to choose a spool directory. So if you mount a RAM disk onto each one of your FreeSWITCH servers, you're able to spool to it, and then once the voicemail is done, you can pull off of it, drop it into the storage link, and it goes out to your distributed storage. But it's very important to try and find little efficiencies like this, because when you're dumping a lot of data into the system and you want it to be a large scalable system, you're going to try and gain efficiencies at every little spot that you can. So that's basically it. I can open it up for questions and even feedback from the perspective of if you've got ideas or things that different ways that you've done it, you might want to let the audience know. Of course, our glorious sponsors.
You mentioned that you're using GlusterFS for replication of the FreeSWITCH instances. Is this for the FreeSWITCH core database map?
No, this is for the storage of the voicemail. So the actual directory where the voicemail files get dropped into, that's where we're using Gluster to spread that out geo-distributed.
Understood. So you're not replicating the core database map?
No, the core database is fed from the XML. So effectively, all of our configuration information, all of our dial plan information for FreeSWITCH sits in a database, in a MySQL DB. We use FreeSWITCH curl to make calls from FreeSWITCH into this package that's available in the contrib, and that effectively builds your dial plan. It will check all of the strings against the dial plan, and then we'll feed out not just voicemail, but conference information, extension information, call groups, attendance. It'll do all of that stuff. I like it for the fact that it gives us this distributed Apache or web server layer that's very difficult to bring down. So the configuration information is always available there for all the FreeSWITCH servers as they spin up.
Thank you.
Thank you. Any other questions?
In the back, behind you.
Yeah, hi. So what would be your opinion on using, because I know you said you could use S3, pooling all the servers, like, I'm assuming FreeSWITCH you could use it to put voicemail similar to Asterisk, you could point it to a directory. So what about something such as EFS, and then using them all to write to that one?
So that's what we do. Effectively, the technology, whether it's like ZFS or just NFS, or if it's GlusterFS, you're effectively mounting the storage directory as a part of the file system. So from FreeSWITCH perspective, the default location, user local FreeSWITCH storage, voicemail default, just gets mapped to wherever the shared storage mount is.
Okay, thanks.
Behind you.
One question. Is this XML provided by the web server, is it cached?
No.
So it's queried every time it needs?
Correct. But there's two ways to do it with this. So the FreeSWITCH curl package gives you the ability to actually just generate your dial plan in the database under conditions, actions. You also can just direct every instance of a string into a single extension, and then use the PHP, and your logic to spit back specifically what you want for that. In the cases of the first scenario that I talked to you about, if you're filling up the DB with lots of different conditions for dial plan, then yes, you could take a performance hit because you're constantly pulling in the whole dial plan every single time you make a call for dial plan. However, if you do it the latter way, where just every dial plan request just gets sent into a specific, piece of logic, if you will, where you can make a determination based on the dial string, if it's voicemail, a conference call, if it's an external dial, whatever it is. You're not using the dial plan to parse through that string and give it all the options. You're just taking the string, dumping it to the logic core and saying, just give me what I need for the string.
Okay, thanks.
Yep.
Other questions?
Right up here. Nisan, give me your mic.
No,
Don't be selfish. Oh, you've got them both. Yes. I'm sorry for accusing you of being selfish. In the back.
Oh, sorry.
More of a comment really on my experience with something that was set up very similar. When I first set up my system, I used Galera and distributed it two in Europe, one in America, and it was working great until we started to use it a lot more for not just voicemail but a lot of read and write heavy data. Our experience wasn't good because as soon as we had the transatlantic delays, we ended up having the whole database lock up, and we had a bad experience with it. So I think it's just worth mentioning that although if you haven't got really write heavy, Galera is great and probably can work multi-data center. For us, it definitely didn't work, and generally I think most deployments are not multi-data center. So just I suppose a little bit of a warning in case anybody trusts it too much across.
I'll say this in association with what you said. I would never use it for CDRs, ever, or logging. Core data, yes.
I would like to add something to it. That was before the segment. Okay. Hi. That was before Galera advertised segment support, segmentation, or after? Because I know that it's now separated to segments.
It was about
for that purpose.
It was about 3 to 6 months ago that we got rid of it. I can't remember what version we were on.
Did you try to use segments?
No, I don't think so.
Okay.
Makes a big difference.
Yes.
I know exactly where you're going.
Okay.
Yeah.
I'll look into that. Cheers.
Because really, at the end of the day, what it's promising, like this Holy Grail, it's worth chasing. Any other questions? I have a question. Yes?
I have one. Do you have a slide with the mother of dragons too?
No, I didn't, unfortunately. I was thinking about putting her in, but it was just a gratuitous sex scene, so.
Okay, thank you, Alex. Let's have a big